In this theorem, we will prove that there exists an irrational number r such that r square is equal to 2. Here r is an irrational number whose square is equal to 2. We will prove this theorem by the contradiction method. What is contradiction method? The contradiction method is that method in which we take a statement opposite to the given statement. So what is the given statement? In the given statement, r is an irrational number. But we will suppose here r is a rational number because we want to solve it by the contradiction method. In contradiction method, as I have already explained, that we take the opposite statement. Given that r is irrational, we will suppose that r is rational. Okay, here we suppose r is rational such that r square is equal to 2. As r is rational, then it means that what are rational numbers are those numbers which can be written in the form of p over q. And when we talk about p and q, what are p and q? Where p and q are the integers, these belong to integers, and q must not be equal to 0 by the definition of rational number. Okay, so remember that when we talk over here, the greatest common divisor over here, the greatest common divisor of p and q, okay, GCD, greatest, G mean greatest common divisor, GCD of p and q, GCD of p and q must be equal to 1. Okay, when we reduce means when we convert p over q into lowest form, when we reduce it, just like 4 over 8, what is the lowest form of 4 over 8? It will be 1 over 8. Okay, so the greatest common divisor of 1 and 8, 1 and 2, of course, is 1. Okay, so the greatest common divisor of p and q is equal to 1. Once again, I would like to repeat this, okay, as I described that, just like 4 over 16. So what is the lowest? What is the 4 over 16? If I take over here the 4 over 16, so what is the lowest form of 4 over 16? It will be 1 over 4. And what is the greatest common divisor of 1 over 4? It will be 1. Okay, so when we reduce p over q into lowest form, then the greatest common divisor of lowest form, the number in the numerator and then the denominator, will be the number which will be divided, the greatest common divisor, GCD, will be equal to 1. Okay, so now we will take the square. We will take the square of r is equal to p over q. If I take the square, then it will be just like as r square is equal to p square over q square. It will be p square over q square, and we can write it just like as, and we know that p square over q square from here. Okay, from here r square is equal to, from here you will see that r square is equal to 2. So when we put over here 2 is equal to p square over q square, and we can write p square is equal to 2q square. From here you can see that 2 divide p square, and of course if 2 will divide p square, then this implies that 2 will also divide p. Okay, where p is an integers. Okay, for example, if I would like to take the example of this one, p square is equal to 2, because 2 is multiplied with q square, and of course 2 will be divided on the left hand side, which is p square. Also you can see that the right hand side is an even number. 2q square is an even number. Whatever you will take q, for example you can take 1 2 3 4 5, whatever you will take, it will be even. The right hand side is an even number, and of course left hand side is also is an even number. So it means that 2 will divide this even number. Okay, so even number means that square of, just like we cannot take 3 over here because this is also even. If we'll take p is equal to 3 square, then it will be 9, which is not even. So it means that we can take just like 4 over here. So if 2 divide 4 square, then it means that 2 will divide 4. If 2 divide 4 square, then it means that 2 will divide 4. Okay, and since if 2 will divide p, then it means that we can take, so let p is equal to 2t. P is equal to 2t, and what is t? T is also an integer which belong to z. T is also an integer which belong to z. So putting this value in, yes, putting this value, p is equal to 2t, putting this value in the, putting this value okay, putting this value over here, p square is equal to 2q square. Okay, when we put over here, it will be 2t square, 2 and t square, which will be equal to 2q square. Okay, 2q square, which means that 4t square is equal to 2q square, and you can write 2t square is equal to q square, or simply we can write q square is equal to 2t square. In the similar way as we have did in the previous, just like as 2 divide p square, then this means that 2 also divide by p. Similarly 2 will divide q square. This implies that 2 will divide q square. Okay, so if 2 will divide q square, then this means that 2 will also divide q. Okay, so 2 divide by p and 2 divide by q. So this means that the greatest common divisor of p and q from these two statements, okay, yes, from here and from here, you can see that the greatest common divisor of p and q, this is equal to 2. But from here, the greatest common divisor of p and q is 1. Okay, from here the greatest common divisor of p and q is 1, and what our result over here? Our result over here is that the greatest common divisor of p and q is 2, which is a contradiction to the given, because if r is rational, then the greatest common divisor is 1. So here, what was before, what we have supposed, and here our result is against our supposition. In our suppositions there was a result. What was that result? The greatest common divisor of p and q is 1 in our supposition, but over here we get a contrary, we get an opposite result to the supposition. So it means that our supposition, there is a problem in our supposition. Our supposition is strong. What was our supposition? R is rational number. This is actually wrong. So what is true? The true is that R is actually irrational number. This is not rational. R is an irrational number. So this complete our proof. Thank you.